Okay, so yeah, let us start. We have some announcement. Watch lectures online. We have quiz 3 this week and quiz 4 next week. For the next week, we will do activity 8 in lab 4. And today, we will be doing activity 6. So please open activity 6 and please go through it. In time. Okay. Can you please distribute? This is your previous activity sheets. And you please distribute this.
It'd be better if we just like put them somewhere and let people come and grab them. So I don't know anyone's name.
Okay, so give some numbers. Yeah.
Oh.
Okay, give someone else.
I don't think
You can distribute that.
Sasha?
Yeah.
Michael?
Amy Cotner. Okay. Sarah.
Here. Elizabeth?
Marissa.
Leah?
Elizabeth. Hannah. Diane. That was Diane.
Oh.
Mark?
Mark. Yeah.
Robert?
Sasha.
Randy?
Courtney. John.
So,
John Polish. Chelsea. 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 Lady Chelsea.
Hillary?
Amelia.
Hannah?
Amelia.
Michelle?
Kelly.
Here.
Kelly. Oscar.
Kelly?
Con. Can.
Sasha?
Christine.
Diane?
Michelle. Jamie. Allison. Amy.
Jamie? Me, sorry.
Valerie. Valerie.
Lucy?
Hillary. Christine.
Amy Colonel?
Nicole. Brandy.
Dustin?
Brian.
Amanda Boyd?
Natasha,
Meredith.
Lucy,
Christine.
Dustin,
Tasha.
Robert,
Amelia. Russell.
Nikki,
Sean. Gonzalez.
Over.
Shantavia, Courtney,
Okay, thanks a lot.
Katie, Jessica, Sinjin, Amelia,
Okay, thank you. So everybody got the activity sheets? Please check in the web city that your grades are uploaded or not. If not, please let me know. Okay, so today we are going to do some statistical analysis on some relationship between variables like length of forearms, length of feet, and height. So I have given to all benches measurement tape. Please measure your forearm, your height, and foot length, and write it down. So that's the collection of data, the first phase of statistics. Oh, I'm short of that, so I will give. Okay, thanks a lot. So we have the data in the machine now, ready for statistical analysis. Everybody write it down.
How can you insert a row if you skip one?
What happened? Let me see. Let me see. What do you want?
Insert row. Okay.
Okay. Write it down. Up to 37 row. And please check everything. Oh, what happened? Oh, just delete that. What happened? Again it came? Okay. Okay. Okay, completed? Okay, let us start the regression analysis. So, to do that, to go stat and then regression. Please don't go to regression here. Go to fitted line plot. That's same actually, but it's easy. It does the same job like regression. So click here. And you have in the left all the variables, forearm, height, and foot length. So for the first question, we have X forearm and Y foot. So double click here, foot length, and X is forearm. So double click here, and OK. Any questions?
Where did you go to do that?
Yeah, stat. Go to stat. go to regression, and oh no, one, cancel that. Yeah, go to stat, regression, and fitted line plot. Yeah, okay. Any problem? Any questions? We have the fitted line here, the simple linear regression equation. So write it down here. No, we are doing that. That's for forearm and foot length. Okay, so write it down here. The first, yeah, blank, and then we are calculating small r. What is small r, by the way? What is r there? What is r? Correlation, yeah. The r is the notation of correlation coefficient, which measures the degree of association between two variables. So we have two variables here, forearm and foot length. How much associated is the two variables? To find that, we will measure r, correlation coefficient. Now, how to measure r? Any suggestions? How to measure r? No suggestion? Square root of? It's written here. Okay. So square root of r square. But keep in mind that this capital R square is not small r theoretically. Mathematically it's same, but this r square, capital R square, has different meaning. But mathematically the values are same. So now to find small r, how to do? Take a square root of point. Why not 38.1? Yeah, so that's percent. So you have percentage. So 38.1 divided by 100, convert it to decimal points, and then take a square root. Keep in mind that the correlation coefficient can't be greater than 1. Correlation coefficient smaller lies between -1 and +1. So alternatively, we can go to stat, basic stat, and correlation. And we have two variables, forearm and foot. Forearm, foot length, okay. So it's 0.617. Any question? Clear? Yeah.
Did you say that for the correlation coefficient that you, when you get the percent for the R squared?
Yeah, if you have r square in percentage, then divide it by 100.
Okay.
Divide it by 100 and convert it to decimal, and then take square root.
Okay.
Okay? Because correlation coefficient can't be greater than 1.
Did you say square it or square root?
Square root. Square root. Okay. Now come to second part, where x is foot and y is height. That means again go to stat, regression, fitted line plot. Now x is foot. X is foot. So delete this, and x is foot. And what is y? Height. So okay. Okay. Here is the regression equation. Write it down and calculate the correlation coefficient similarly, like before. So what is that? Let me see. stat, basic stat, correlation, it's foot length and height. So delete foot length, height 0.891. Okay. Now again the last part, forearm and height. X is forearm, X is forearm, and Y is height. So Y remains same. Delete this and double click on forearm. Okay. This is the regression equation, and you have the R square. To calculate the correlation coefficient, go to stat, basic stat, correlation, give height and forearm. Okay. So 0.701. 0.701. Graph? Yeah, we want to graph. This graph or this one?
The forearm and height.
Any question? Now I have a question. Why we are taking R positive? Why we are taking correlation coefficient positive? How to determine that the correlation? We are taking square root, and we will get the value of R, but not the sign. So how to determine the sign of R? Yeah?
Positive correlation was positive.
Why positive? Slope is positive. So in this equation, the slope is positive. The sign is positive here. And that's why the correlation coefficient is also positive. Any questions? Understand? So whenever we have any regression equation, first look at the sign, find the correlation coefficient value by taking square root. First, if you have percentage, divide it by 100, and then take square root, and then decide the sign, write it down. So your correlation coefficient. Okay? And my next question is how to determine or how to interpret this slope. And that's your question also here. Interpret the slope. So how to interpret the slope? The slope is a mere number. So how to give words? How to give words on the slope? What do you mean by this slope? Yes. Any suggestion?
Me?
Yeah. What do you mean by that slope? Height is equals to 40.99 plus 2.593 forearm. What do you mean by 2.593?
For every 1 increase in inch of forearm, you will have a 2.593 increase in height.
Ah, great, great. But if we increase forearm 1 inch, then height will increase 2.593. But if we decrease forearm, then
Then you will decrease.
decrease. That means if I change the forearm by 1 inch, by 1 unit, here unit is inch. So if we change forearm by 1 inch, then the average change in height, note it down, average change, that's important, average or expected change of height is 2.593, the slope. So write it down for all the 3 parts. but just make sure that you write the variable's name correctly and the quantity, the slope correctly. But the interpretation is same. So if we change x, the independent variable, by 1 unit, here unit is inch, then the average or expected change in y is the slope. Any question? Any doubts? Clear? Great. Write it down and finish question 3. We will now go to question number 4. Completed? Okay. So what is question number 4? Which variable is best to use when predicting height, forearm or foot length? Explain. So we have 3 variables. Now we want to predict height, and we have another 2 variables like length of forearm and length of foot. Now to predict height, which is better variable, forearm or foot? Why foot? Because loudly.
The correlation is stronger, closer to 1.
The correlation is stronger. Correlation between what? Foot and height. So correlation between foot length and height is close to 1 and stronger than the others. We have 3 correlations in question number 3. Among the 3, the highest is the correlation between foot length and height. So if we want to predict height, the best variable is foot length. Any question? Sorry. Clear? Any? Yeah. Sorry. 1 minute. Yeah. Can I repeat?
Yes.
Okay. Sure. Now see, you have the 3 correlation. Just yeah. You have 3 correlation like 0.617, then 0.891, and then 0.071. Okay. Now, if you have say y height and x you have foot or forearm, which is stronger in terms of correlation? Foot and height? Foot and height. This correlation is stronger. It's close to 1. It's greater than 0.071. So that's why if we want to predict height, then the best variable should be foot length. Clear? Questions? Clear? Come to question number 5. What's that? Why do we not interpret the intercepts in these cases? Loudly. Say it loudly.
You can't have a length of 0.
You can't have a length of 0. Because if you want to interpret this number, you have to put 0 to this variable. But there's no meaning. Length of forearm is 0. No meaning. So that's why we can't interpret the intercepts of linear regression in these cases. Any question? Clear? Clear? Yep.
For the forearm and foot, interpreting the slope,
Hmm.
is it saying if you change the forearm, if you increase the forearm,
If you change, increase or decrease, if you change,
if you change
yeah.
by an inch,
Yeah.
then the foot size will change by 0.5.
Yeah, foot size will change by 0.5 in average. In average.
Do you need to put the numbers like inches? Like I just put it.
See, unit is fine, but here we are using inches, so that's fine. That's not a problem.
You don't have to put the
No, that's okay. That's okay. That's fine. Any questions? Okay, so Great. Over.
Thank you.
Thank you. Thank you. Thanks. Thanks. Oh, thank
Thank
you.
you very much.
Thank you.
Thank you.
Thank you. Thanks. Okay. Good. Okay. Okay. 1 minute. Thank you. Thank you.
Thank you.
Thank you.
Thank you.
Thanks. Thanks. Thank you. Yeah. What's your question?
We don't interpret the intercept because we don't calculate zero. So
No, no, no. Because these variables, this length can't be zero.
okay. So
Your
like
foot
to-
size can't be zero. Your length of forearm can't be zero. Your height can't be zero.
So to interpret
So-
intercept, we plug in numbers.
Yeah, we plug in zero here.
Oh, okay.
So you have y equal to a plus bx. Y is equals to a plus bx. Now to interpret a, you have to put x equals to 0. But here, the length can be 0. And so, here. Thank you. Oh, yeah, sure.
Why is the foot length better to use?
Okay, why is the foot length better to use? Now you can see here that the correlation between foot and height is 0.819 and the correlation between forearm and height is 0.701, which is
Oh, so then
This
is better.
yeah, so that's great. Thank you.
I'll look for you though. Alright, what's your working summary? Thank you.
You understand that thing?
Yeah.
Okay, thanks.
That's okay, I don't know. Anything over there.
Okay, thank you.
Thank you.
Okay. So clear? Understand? Yeah. Okay. You have any question? Yeah.
In the equation, I always get confused of which part is supposed to be the y-intercept.
See, you have which part?
Which part is supposed to be considered the y-intercept? It's the 4.66.
This is intercept.
Okay, and that would that be the foot length is the intercept?
Yeah. Foot length is equals to intercept if the forearm is 0.
Okay.
But
You can't.
forearm,
so-
yeah, you can't give forearm length
so
of forearm.
you
0.
can't
You can't interpret. You,
because the
because
because
the
the forearm can't be 0.
because the variables like here x
Okay.
x can't be 0 here.
Okay.